Hi everyone. Hello.
Hi.
Welcome to this PopcornFX 2.23 release live stream. So we'll start with the version status and release cycle as always, and then we'll see new features, more details on new asset generator stuff, and then the demo. We have simulation examples, but that's a miss. Actually, there is no simulation example slide, so we'll go straight to the demo. So release cycle, we are here before 224. We released 224 at the end of March for GDC or around GDC. So about new simulation and rendering features, we now have interlayer fences. So before you could use fences inside a layer to say that a bunch of nodes had to wait for other nodes to finish across all particles. Now you can use fences between layers. Now you can use fences between layers to tell that here, for example, layer B has to wait for layer A to finish all its computations. So this is useful when you want to write layer A to write into a grid, for example, and layer B read from that grid, but it needs to be sure that all particles from layer A have finished processing. Then on the GPU sim side, we have an experimental D3D12 Ultimate implementation of GPU sim events using work graphs. So that's, for example, trails. So now a GPU simulated layer can trigger child particles, can spawn child particles. It's still very experimental. You can enable it in the user preferences. Um, and yeah, it's still very experimental, but at least you can start experimenting with it. On the GPU sim side, we can also now sample submeshes of a mesh. This was something that broke the feature parity between CPU and GPU sim before. So if you had attributed samplers with multiple submeshes, you couldn't ask the sim to sample all the submeshes. Now you can. And on the rendering side, all billboard materials, so that's the new materials, not the legacy materials, now have a pivot property. Before you had to use the billboard string controls template and rewire everything through that template and then into your renderer to kind of fake a pivot. Anyway, now you have this built in the properties of the renderer, and it allows you to offset the center of rotation of the billboard, for example, or the center of scaling, dynamic scaling. In the templates and corelib side, a bunch of miscellaneous things. When you intersect meshes, you now have an option to say that you want to intersect the back faces of the meshes. Before it was only intersecting from the outside in, so just the front face. There are a bunch of grid array operations now, so you can basically do sums on grids. So something you would use loops for, but because we don't yet have loops in the graph, this is kind of a hack to fake loops and yeah, array operations. You have perspective to orthogonal viewport switch now, also in the effect editor viewport, and a bunch of improvements on the effect interface panel, mostly related to the categories. Before it was pretty painful to create new attributes and place them into categories. Now you can directly create attributes inside the category or drag and drop attributes between categories, and everything works as expected. So on the asset generator side, for the texture generator, we added a bunch of new generators. So in 2.22, there was a node graph generator. We also now added an atlas generator, so it's the one you see on the top right here. You can specify a list of textures and you have various packing options where you can tell it to pack it into a regular grid or to do a dynamic packing without changing the texture sizes. So yeah, it allows you to build your atlases more easily. We also added a font atlas generator, so you specify a font file, a list of characters you want to add in your atlas, and it will raster that font file into the texture automatically. And Then this here on the bottom left, it's the BAT generator. So the BAT stands for bone animated textures. So it basically takes a mesh, an animation, and bakes that inside the texture. So each line is a bone, corresponds to a bone, and you actually have multiple lines per bone for the translations, rotations, etc. And then multiple animations are stacked on top of each other, and that's what you can use with mesh renderers to have skinned particle meshes, basically. You have a button down there that will copy to the clipboard a renderer node set up with this texture and the proper parameters. Before you could do that from the mesh importer, it was kind of a shitty pipeline. Now, because it goes through the asset generation, it can be automatically rebuilt whenever the source mesh changes. So it should be a much more streamlined workflow. And last but not least, we added a generator that takes a custom Python script and generates a texture from that Python script. So that basically allows you to do pretty much anything you want. Arthur will do a demo afterwards of the Python generator. On the mesh generator side, we added a new option for a base mesh generation. So you can now generate multiple planes in a cross-plane fashion. So you just specify the number of planes and it will generate that. And then this can be piped into your graph where you then modify the vertices and all that as usual. Vertex off. And a handy feature that we had in 2.23 was is the rebuild normals and rebuild tangents. Before you had to compute if you deformed the mesh, you had to compute the deformed normals and pipe them into the output node. This could be painful. For example, this is just a noise, so you would have to compute the proper noise normals, parametric normals from the noise. Now you just check the checkbox rebuild normals and it does it for you. So that's nice. And a new generator that wasn't in 2.22 is vector fields. So vector fields also now have their own graphs, so you can procedurally build custom vector fields. Here is just a simple graph that takes the distance of the voxel, the current voxel to the center, the vector from the center to the voxel, and uses that. It does a cross with the vector, and it basically makes a swirling vector field. And here on the bottom right, you have the animated version of that. So it also supports multiple frames to generate multiple frames. So it's an additional input. You have the animation cursor, so you can change the vectors per frame based on this cursor. And that's it. Go to the demo. Which you want to start?
I'll begin. So I'll start with the BAT generator. So it takes this mesh here and these two animations, and in here I generate the BAT for both animations. So I have the mesh specified and the two animations, and then I can just copy the renderer to the clipboard and use it in my effects. So here is the renderer with a simple blending of the animations. Here is the billboard pivots. So before you basically had this, so they will scale around their origin, but now you can set it so that they will behave differently according to the settings you put it in the pivots. Here is for the multi-plane mesh assets. Here is a simple solar coaster. So I have a 3D curve that defines the position of the ribbon, and then I move it around so it fits the curve. and the texture atlas. So I have here selected a few images and I've packed them into an atlas automatically.
Sure. So for the Python generator, I can do the basic demo. So, I have this texture which is generated by this script right here. I use by, but basically you just fill an array of bytes and you can tell it to generate uh, in whatever the dimensions you want. It also works for 3D textures.
Can you maybe zoom a bit in the script? Oops.
Yeah.
People that we watch it can
Yeah.
go then.
This example will be in the documentation when the after the release, so you'll be able to understand better. There's another common use case is probably uh, fetching an API. So here we just use the cat API.com to fetch an image. Pretty kitties. And the final one is maybe calling right here we use F3D to generate a thumbnail of mesh. Here there's an arguments string which is passed to the script, so you can put anything you want. And here it's just to be able to give the script which mesh you want to generate the thumbnail for easily. And of course it's able to give the dimensions. Something I forgot to mention actually. The fetch is that for some scripts you don't want actually to have fixed dimensions, so you can just ignore it in the script. And here you see it gives a different image size every time. And that's it for the images.
So I will now show a few R&D that we did. So I'll start with the L systems. So it uses the standard L system syntax. So you basically give it a string. So here is the premise and then your rules. So it's like any L systems. One line is one rule, and then it generates the L system. So of course, because this is popcorn, you can use events. So for example, here I have a flowery branch, and in the rule set, I have specified that um, I want to trigger events. So the events are these numbers here, and essentially when it will trigger a custom event that you can then use to trigger whatever you want. So here I'm just creating a flower or a leaf, but you could spawn a brand new effect or whatever you want. And also pathfinding. So here is some research and development for single agent pathfinding. So here is the environment, and this is the brains, sort of, the agents, and they can use this data to navigate through the map.
So this is actually a grid visualized with a
Yes.
debug visualizer.
Yeah.
And the grid is used to
store the vertices where the agent should go to.
Next.
Yes.
Okay.
Yeah. So it stores the path essentially. And we can also do crowds. So this is a bit more actually simpler, but So there are 4 teams that each go to their designated target. It uses a Jinxtra map, so each agent is able to move where they need to with very little computation needed for each agent, as each path is essentially already pre-calculated. There's also agent avoidance, very basic agent avoidance, so they will not usually collide with each other. And here is another example of pathfinding with multiple goals. And the navigation here happens on a nav mesh, as previously it was on a regular grid. So this allows for multiple levels, stairs, whatever. So yeah, each agent will wait for a train to be here, to be present, and then enter the train whenever they can. They're a bit impolite, they're waiting in front of the door.
Just like in Paris.
Yeah. Yeah.
Yeah, so these are, as Benoit was saying, examples of internal R&D we're doing. They'll probably at some point end up as example packages on the marketplace, just to show how you could do stuff like that. Right now, they're not really ready yet, but yeah, we're just showing some of the stuff we're working on internally.
Yeah.
Okay. Well, that's all for us. Questions, as usual, you can find us in the Discord. Like it. Well, thanks everyone, and see you on Discord.
Bye.
Bye-bye.
Bye.